To assign formal charge, you take the number of valence electrons in the free atom, or the number of valence electrons the atom is supposed to have, and from that you subtract the number of valence electrons in the bonded atom, or the number of valence electrons the atom actually has in the drawing. So let's assign a formal charge to carbon in the methane molecule. Remember that each bond consists of 2 electrons. So I'm going to draw in these electrons in these bonds because it's going to make it easier for us to assign a formal charge to carbon. So to find a formal charge for carbon, the formal charge is equal to the number of valence electrons in the free atom, or the number of valence electrons that carbon is supposed to have. We know that carbon is supposed to have 4 valence electrons, so I could write a 4 here. And from that, we subtract the number of valence electrons that carbon actually has in the drawing. Remember when we drew our dot structures, right, we knew that each bond here came from 1 valence electron from hydrogen and 1 valence electron from carbon. So I could give that 1 valence electron back to hydrogen and 1 valence electron to carbon. And so we're going to divide up all of our bonds that way, right? Give 1 valence electron to hydrogen and the other valence electron to carbon, because that makes it easier for us to see that carbon has 4 valence electrons in our drawing. So let me highlight them here. 1, 2, 3, 4. So we're going to subtract 4 from 4. So 4 minus 4 is equal to 0. And so carbon has a formal charge of 0 in methane. Let's do another example, this one down here. You can see it's different because this time we have 3 bonds. So let me draw in the electrons in those bonds, and let's find the formal charge on carbon. The formal charge on carbon is equal to the number of valence electrons that carbon is supposed to have, which we know is 4, and from that we subtract the number of valence electrons that carbon actually has in our drawing. We divide up the electrons in our bonds just like we did before, and we can see that carbon has only 3 electrons around it this time, so I'll highlight those, 1, 2, and 3. So 4 minus 3 is equal to plus 1. So carbon has a formal charge of plus 1. So carbon's supposed to have 4 valence electrons. It has only 3 around it. So it lost one of its electrons, which gives it a formal charge of plus 1. Let me go ahead and redraw that. So over here on the right, we have carbon with 3 bonds to hydrogen. And this carbon has a plus 1 formal charge. So we can represent that by putting a plus charge here next to the carbon. Notice that carbon does not have an octet of electrons around it. It has only 6 electrons around it. And that's actually okay. Carbon can never exceed an octet, but it's okay for carbon to have less than 8 electrons. This is a carbon with a plus 1 formal charge. It's a positively charged carbon, and we call those carbocations. So let me write that down here. This is a carbocation, and carbocations come up a lot in organic chemistry mechanisms, so it's really important to understand them. All right, let's think about the pattern that we see here. All right, we have 3 single bonds around this carbon. Let me go ahead and highlight them here. So here's 1, 2, and 3. So we have 3 single bonds around our carbon, and we have 0 lone pairs of electrons around that carbon. So 3 bonds plus 0 lone pairs of electrons will give you a positively charged carbon, will give you a carbocation. What is the hybridization of this positively charged carbon? Well, there's 1, 2, 3 sigma bonds and 0 lone pairs of electrons. And so from the videos on hybridization, you should know this carbon is sp2 hybridized, and therefore this carbon will have trigonal planar geometry around it. And again, that's important when you do your organic chemistry mechanisms. So carbocations are extremely important to understand. Let's look at some other examples of carbocations and analyze them a little bit too. All right, so let's start with the carbocation on the far left. The carbon with the plus 1 formal charge is this one in the center here. And what is this carbon in red bonded to? Well, the carbon in red is bonded to a CH3 group up here, which we call a methyl group in organic chemistry. The carbon in red is bonded to another CH3 group here and another CH3 group here. So the carbon in red already has 3 single bonds and 0 lone pairs of electrons, and so the carbon in red has a plus 1 formal charge. Let's look at this carbocation right here, and let's highlight the carbon with the plus 1 formal charge. It's this one, right? So So this carbon in red is bonded to a CH3 group on the left and a CH3 group on the right. So we only have 2 bonds here, right? We only have 2 bonds at this point. But we know in order for that carbon in red to have a +1 formal charge, we need 3 bonds. Like the example on the left. The example on the left, we have 3 bonds here to that carbon. And so where is the last bond? The last bond, of course, must be to a hydrogen. Right? So we draw it in here like that. So the carbon in red is bonded to a hydrogen. Usually you leave off your hydrogens when you make these drawings, but it's important to understand what's actually there. Move on to the last example. Right? This time the +1 formal charge is on this carbon in red. And that carbon in red is directly bonded to one other carbon. So that's 1 bond, but we know we need a total of 3 bonds. So the carbon in red must have 2 more bonds, and those 2 other bonds must be to hydrogen. So we draw in, there's 1 bond to hydrogen, and there's another bond to hydrogen. So it's important to recognize these patterns. Let's do another formal charge, right? Let's assign formal charge to another carbon. Let's put in our electrons and our bonds. All right, so we put those in, and our goal is to find the formal charge on carbon. So the formal charge on carbon is equal to the number of valence electrons that carbon is supposed to have, which we know is 4, and from that we subtract the number of valence electrons that carbon actually has in our drawing. So we divide up these electrons here in these bonds, and this time carbon has a lone pair of electrons on it. So how many electrons are around carbon in our drawing? This time there's 1, 2, 3, and then 2 more from this lone pair, so 4 and 5. So 4 minus 5 gives us a formal charge of -1. So carbon is supposed to have 4 valence electrons. Here it has 5, so it's like it's gained an extra electron, which gives it a -1 formal charge. Let me go ahead and redraw that. We have carbon with 3 bonds to hydrogen and 1 lone pair of electrons on this carbon, a -1 formal charge, so we can represent that here with our negative sign next to that carbon. A carbon with a negative charge is called a carbanion. So this is a carbanion, and let's analyze the pattern that we have for our carbanion. We have 1, 2, 3 bonds, so let me write that down. We have 3 bonds. And this time we have 1 lone pair of electrons, right? So we have 1 lone pair. So 3 bonds plus 3 single bonds plus 1 lone pair of electrons for a carbon, right, will give us a -1 formal charge on that carbon. We will have a carbanion. These also come up in mechanisms in organic chemistry. So let's analyze some carbanions. So down here, let's start with the carbanion on the left. And the -1 formal charge is on this carbon, which I just marked in red. So we should have 3 bonds and 1 lone pair of electrons on that carbon. Well, let's analyze it. The carbon in red is bonded to a CH3, a CH3, and a CH3. So that takes care of our 3 bonds. Then, of course, here's the 1 lone pair of electrons. Let's move on to the next example. So the carbon with the -1 formal charge is this carbon I just marked in red. The carbon in red is directly bonded to a carbon here and directly bonded to a carbon here. So that's 2 bonds. I need a total of 3 bonds, right? Because I already have a lone pair of electrons, right? Here's my lone pair of electrons on that carbon. So I need 1 more bond, and that bond, of course, must be to a hydrogen. So I can draw in a hydrogen here. Again, that hydrogen is usually left off when you're drawing dot structures, but it's important to realize that hydrogen is actually there. Finally, 1 more example, right? The -1 formal charge is on this carbon, and that carbon is directly bonded to 1 other carbon. It already has a lone pair of electrons, so far we have 1 bond and 1 lone pair. We need a total of 3 bonds, so we need 2 more bonds on that carbon in red, and so those last 2 bonds, of course, must be to 2 hydrogens. So it's important to be able to assign formal charge and to do the math, right? It's important to be able to do these calculations. But eventually, you won't need to do the math anymore. Eventually, you'll be able to look at a carbon and come up with a formal charge after you've done enough problems.